All right, so we're looking at graphing rational functions. So let's say we have something like this where it's going to be y equals to 2x minus 3 over x minus 3. Okay. So in this situation, we want to find our four-piece information. That is the x-intercept, the y-intercept, the horizontal asymptotes equation, and the equation of the vertical asymptote. With that information, we can graph most rational functions, so we don't have to plug in a bunch of numbers. So to find the x-intercept, we know that we set y equal to 0 and solve. But in this case, if I set y equal to 0 and solve, in order to isolate x, I'm going to have to go ahead and multiply both sides by that denominator, the x minus 3. So it just goes away anyway. The faster way to do this is to set my numerator equal to 0 and solve. All right, so I end up with this. So in the end, x is equal to 3 over 2, or 1.5. Okay, so 3 over 2, comma 0. All right, for my y-intercept, I'm going to let x equal to 0 and solve. So remember, we could plug it in and solve all that stuff, but if I just cover up the terms that have a 0 in it, or sorry, an x in it, it really just becomes negative 3 over negative 3, which is just going to be 1. So this would be 0, comma 1. For my horizontal asymptote, this one's a little bit tougher to get. We've seen situations where the degrees of the highest power of x in the numerator is going to be smaller than the denominator. And when that happens, so if degree of the numerator is going to be less than degree of the denominator, okay, this means that our horizontal asymptotes equation is going to be y equals 0. Okay? And the reason why that is something we'll look at a little bit in here, but mostly it's a calculus topic to take a look at end behavior for asymptotes here. So we'll see that stuff a little bit later on. But for right now, we can go ahead and just look at this by seeing different examples of it. In this situation, though, we have, if the degree here, or the degree is the highest power of x, in this problem, the degree of the numerator is 1, and so is the denominator. So if the degree of the numerator is equal to the degree of the denominator, there we go, your horizontal asymptote is going to be y equals to, and then it's the ratio, so the fraction, of the leading coefficients. And so remember, leading coefficients, in this case, coefficient, abbreviate that, is going to be 2 over 1, right here. So 2 over 1, and so it's just the coefficient on the largest, the variable with the highest exponent, right? So 2 over 1. So it's just y equals 2, because it's a horizontal line, y equals 2. Okay. The vertical asymptote, that's when the graph is going to be undefined, because the graph doesn't exist on that vertical asymptote. And what makes a function undefined, in this case here, is what makes the denominator equal to 0. Okay. So if I set my denominator equal to 0 and solve, I end up with x equals to 3. And that's going to be the equation of my vertical asymptote. Okay. So when I go and take a look at putting all this together here, x equals 3 is out here, okay. Y equals 2 is over here. Okay. My x-intercept is 1.5, comma 0, and y-intercept is at 0, 1. So for our purposes right now, the graphs will not pass through the horizontal nor the vertical asymptotes. So remember, keeping in mind, the graph has to come from an asymptote and go towards an asymptote. So on the left-hand side, in order to make this work, I can see that coming from an asymptote, passing through those x-intercept and the y-intercept, and then going right along that horizontal asymptote. It'll look like that. We also talked in class about the idea of multiplicity, which is how often an answer will appear. Right? So in this case right here, the vertical asymptote has a multiplicity of 1. Right? Remember, it's not is the actual number that's representing that equation odd or even. It's the number of times that it shows up. So this is just x minus 3 equal to 0, so 3 only shows up once, right? So we know that if the multiplicity is going to be odd, the graph will alternate directions that's going on either side of the vertical asymptote. So in this case, as I approach that vertical asymptote from the left-hand side, it goes down towards negative infinity, right? So that means the other side is going to alternate, and it's going to go up, meaning that it's going to have to be trapped up here and go right along here. So once again, coming from an asymptote and going towards an asymptote. Okay? And that's our graph.